controls lab is, to me, probably by far the most valuable lab that I've had here so far, and quite possibly one of the most well-constructed labs. That lab's been valuable to me because controls is very, very theoretical and conceptual based. There's no tangible element there at all, and you're working with imaginary numbers on an imaginary plane, and then transferring it back into a real domain result, real-time domain result, and somehow it works. So, being able to see the block diagrams and the math models and the Simulink controls and the structures, the computer logical algorithms, and then you can play with those, manipulate them all day. You can put polls on the Laplace domain, but to me, again, that has very little value to me. But to see it from a programmable standpoint and how you can change the response of the system by just tweaking a gain value, that was illustrated in the lab, and that's when I've really started to understand, this is what those poles are doing. This is what those zeros do. If you want to reduce your response time or your overshoot of a system, this is what it does. So yeah, that has been by far the most helpful lab to me. And they have a nice, it looks like a purpose-built setup for that kind of operation, where they have all the different parameters and values that you can change, and different control structures that you can play with. And it's not, we started out with a motorized cart system, and we've now progressed into fluid control, and I think we're even going to do some more like airflow kind of things, or temperature-based control systems. So you definitely even get a broad mechanical controls introduction in that. So.